Chapter 14 is multiple regression analysis. This is the last chapter for this semester. Multiple regression analysis is actually analyze the relationship between the dependent variable and several independent variable. So dependent variable, based on the name, it says this variable it depends on the value or the change in the value of the other variables. Then the other variables we call that independent variable. For example, we want to know, now it's winter time. We want to know the heating cost, the relationship, what kind of factors affect your heating cost. So here the dependent variable is the heating cost, where the other factors, other variables, for example, the temperature outside and the insulation in your house and the age of your house and if your house have the garage or not. All of these are factors, or we call them variables, which may or may not affect your heating cost. So we call all of these variables independent variables. We use a formula or the equation here to describe this kind of the relationship. A general multiple regression with a k independent variables is given by y hat. We call it y hat. Y is equal to a plus b1 b sub 1 x1 plus b2 x2 plus b3 x3 plus and plus bk sk. So y here is a dependent variable. In our example, that refers to the heating cost. Why we use a y hat? Because it is an estimated cost. Okay. Because this heating cost is based on the the values of all of the factors and all of the values of the factors based on the sample we took. So this y is not the actual value of the heating cost. It is just the estimated value of the heating cost. So we use a y hat designated it. Okay, a is a constant number. It's a y-intercept. What does that mean? Means when all the variables x1, x2, x3, xk, all of the variables equal to 0, then what's the number or the value for the y? So a is a y-intercept. Okay, b1 is a net change in y for each unit change in x1, holding x2, x3 until like xk constant. So x1, x2, xk are all what I said, the independent variables. Those, the variables which might affect the value of the y. So b1 is actually the coefficient of those independent variables. So b1 is a net change in the y for each unit change in x1. If we assume x1 is the outside temperature, so b1 is actually means the net change in y for every degree increase or decrease outside. So it is called a partial regression coefficient or just a regression coefficient. So determine ignore this sentence, skip this sentence, because we don't need to know about that for this class, for this course. It's just talking about how we developed this equation. Okay, determine the b1, b2 is very tedious, so a software package such as Excel or Minitab is recommended. So that means with the help of the Excel or Minitab, and we can find out the b1, b2, b3, and new bk. So that means with any given data, we can figure out an equation like this. So means we can find out the value of the A and B1 and B2, B3, BK. So in that way, once we find the equation like this, then for any, the data or the values we get from the sample for the x1, x2, x3, or xk, we can get our estimated y value. Let's check this out with an example. Okay, here it is. This realty sells homes along the east coast of the United States. One of the questions most frequently asked by the prospective buyers is, if we purchase this home, how much can we expect to pay to heat it during the winter? The research department at this realtor place, has been asked to develop some guidelines regarding the heating costs for the single-family homes. 3 variables are thought to relate to the heating cost. First, the mean daily outside temperature. Second, the number of inches of insulation in the attic. And the third, the age in the years of the furnace. So to investigate this research department selected a random sample of the 20 recently sold homes. They collecting some data from the samples. It determined the cost to heat each home last January as well. So here are the data. So if we find out all the data for the heating cost and for the mean outside temperature and the insulation and the furnace, and how can we develop the equation so we can use that equation for all homes, not only for these 20 sample homes, for all the houses. So in that way we can introduce this part regarding the heating cost to the potential buyers. How do we do that? Let's check out how do we use Excel to find out all the coefficients for the independent variables as the B1, B2, BK numbers. Okay, let's start with Excel. Here are the data, the heating cost data, the data for the outside temperature, insulation, and the age of the furnace. First thing, please check if you have the data analysis in your Excel. So click the data to say if you have the data analysis. Okay, you don't have the data analysis here, then go to this Windows sign, the Office button. Okay, my Excel is like a 2007 or something. If you have the newer, like a 2010, the version of the Excel, you may not have this thing, but there is like a file. Okay, files here. So click your files, find out the Excel options. If you do not have this window sign, it is just the file, then you have the options, on this list, in the menu list here. So you just find out the name, the options. Okay, so click the Excel options, then click in this list of the menus, click the end-ins. Okay, in the end-ins, what we need is an analysis toolpack of VBA. So I just click the analysis toolpack add-ins. Then go to the bottom here, says click go. The small windows pump up. Then click here, analysis toolpack of VBA, then click OK. Here it is, the data analysis. So now select the data analysis, then select regression, then click OK. Okay, make sure in the input Y range you select the A1 to A21. for the input X range, select B1 to D21. Okay. Then click labels. Then in the output range, you can select any cell you want where your output gonna go into. For example, we can click H, like a F9. Then check the labels, and then okay, everything. Remember, check the labels, then click OK. Okay, here you go. We have the summary output here. We have the summary output here, and let me bring. Here is the summary output we need for the following chapters. Following slide. I'm sorry. So here are the coefficients. Okay, for the temperature, this negative 4.58, those numbers, these one numbers, is the coefficient for the temperature. If temperature is x1, then this number is a b1. And here is the coefficient for the insulation. It's negative 14.83. Here, this 6.10 is the coefficient for the age of the furnace. Okay, and here are the degree of the freedom for the regression. We will talk about this a little bit later. Okay, the degree of freedom for the regression, degree of freedom 16 for the residue, and the degree of freedom 19 is total. And here the regression, residue, total together are talking about the variations. Okay, let's go back to our slides. Here you go. That's the multiple linear regression Excel example. We got the exactly same thing as the slide. So the first one is the intercept. That's our A number. The second one is the coefficient, the B1 for the temperature. This one is a B2 for the insulation. This one is a B3 for the age. So based on those numbers, we can get we develop our equation. So y hat equal to 427.194. That is the number for the intersect. Is actually the constant number is A. Here we substitute the B1 with the number we got with the Excel, and substitute this one with the B2 and this one B3. So here is the equations we got. So how do we interpreting the regression coefficients? The regression coefficient for the mean outside temperature x1 is 4.583. 4.583. The coefficient is negative because when the outside temperature increases, the cost to heat the home decreases. So for every unit increase in the temperature, holding other two independent variables constant, holding the x2 and x3 constant, monthly heating cost is expected to decrease by $4.583 for every increase, every degree of the temperature increased outside. The anti-insulation variable x2 also shows an inverse relationship, negative coefficient. The more insulation in the attic, the less of the cost to heat the house. For each additional inch of the insulation, the cost to heat the home is expected to decline by 14.83 dollars per month. The age of the furnace variable shows a direct relationship. With an older furnace, the cost to heat the home increases. For each additional year older, the furnace is, the cost is expected to increase by $6.10 per month. So apply the model for the estimation. What is estimated heating cost for a home? If the mean outside temperature is 30 degrees, there are 5 inches of the insulation in the attic, and the furnace is 10-year-old. So the estimated heating cost equal to 427.194 minus 4.583 times 30, because the first independent variable is 30 here, minus 14.831 times 5, because the inches of insulation is 5, and plus 6.101 times 10. The age of the furnace is 10-year-old. Then we get the heating cost for this kind of the house with 30 degrees temperature outside and 5 inches of insulation, and the 10-year-old furnace is 276.56 outside the heating cost. This is just an example. So actually we can bring in a lot of the factors, a lot of the independent variables which affect the value of the heating cost, the dependent variable here. So we really need to know which variables does have the significant coefficient, means which variables does matter in the estimation of the heating cost. So we need to do the next testing. We need to do some investigation to investigate whether any of the independent variables have significant coefficients. We call that global testing. So testing the multiple regression model. When we do this kind of the testing, we have the hypothesis is given. It's not like in the last chapter we have to figure out the sum here. And in the last chapter we mainly did the hypothesis on the population mean, and here we just want to testing the independent variables if they have the significant coefficient. So the hypotheses are the HO equal to the beta 1 equal to beta 2 equal to beta k equal to 0. H1 is not all betas equal to 0. So what is the beta thing? In our equation we use the B1, B2, B3 as the coefficient, but that's only for the samples. When we took samples and then we developed the equations, we use B1, B2, B3 refer to the coefficients for each independent variable. But for the population, for the whole population, for the population data, the coefficient, we use the beta to designate the coefficient. So HO is all the coefficient at 0. What that means if the one coefficient is 0, means that variable, that independent variable, does not matter. Does not matter in explaining the change in the dependent variable. Use our example. If the coefficient for the age of the furnace is 0, what that means the age of the furnace doesn't matter in explaining any change of your heating cost. Okay, so H1 is not all betas equal to 0. What that means at least one beta, means at least one coefficient does matter, because at least one beta does not equal to 0. Okay, decision rule. Step 2, decision rule. Okay, here we do not use the z distribution and z value. We use F distribution. Okay, we use F distribution, and the critical value is F sub alpha k and k minus n minus k minus 1. So this F value, we can get it from our summary, our Excel output. So reject HO if f greater than f alpha k n minus k minus 1. So first, this f value here, it's the test statistic. Okay, so the f test statistic, how do we find that number? It is in here. Okay, go back to the Excel sheet. We just performed our the data analysis. F value is here, equal to 21.90118. So you find out the F value. Then the critical value, for the critical value, we need use the F table. So alpha is the significance level. Usually it is a given information. Okay, so K is the degree of the freedom I just mentioned. K number actually is the degree of the freedom for the regression. And n minus k minus 1 is actually the degree of the freedom for the residue. So we can get the k number and n minus k minus 1 numbers in the output, the analysis output. But actually, you know, the k number is the number of the independent variables, and n is the sample. If all of these two numbers is not given in the questions, then you can find out here. So here is a k number. So k number is the degree of freedom for the regression. So k is 3. We know that, right? There are 3 independent variables in this question. It's the temperature, insulation, and age. And n minus k minus 1 is n is the number of the samples is 20. So 20 minus 3 is 17. 17 minus 1 is 16. That's how we get it. So it's also the degree of freedom for the residue is 16. If you cannot get those information from the questions, you can get that from your data here, 3 and 6. So okay, after we find out the R alpha and the k and the n minus k minus k, how do we use the F distribution? Let's check the F table. Okay, so for this question, the significant level alpha is 0.05. So 0.05. And the first row is the degree of freedom for the regression is the k number. So we got the k equal to 3. That's the number we need. And for the first column is the degree of freedom for the residue. That is n minus k minus 1 number. So our n minus k minus 1 is 16. So let's find out the 16. Then we need to find the number, from the 3 go all the way down until, here you go, this one. So from the 3 go all the way down until to the row started with the 16. So it's 3.2389. It's 3.2389. That's your critical value. Then we compare. We got the F number is 21 point, I cannot say it. Well, anyway, it's 21. And then we got the F, critical value is 3.24. It's rounded up to the 2 digits here. So 21 greater than the 3.24. So what's the result? Result is we reject the non-hypothesis. What does that mean? That means at least one, the variables, the coefficients that matter in explaining the change of the heating cost. Okay, check this slide is computed the value of the F is 21.9, which is in the rejection region. because it's greater than the 3.24 is the critical value. The non-hypothesis that all the multiple regression coefficients are zero is therefore rejected. Interpretation: some of the independent variables, amount of the insulation, maybe do have the ability to explain the variations in dependent variable heating cost. That's it. So for this chapter, what you need to do is you know how to use in Excel data analysis to find out the the analysis output, the regression analysis output from the raw data, and then develop the equations, and then you can get some estimated the dependent variable numbers with given information, and then you need to learn how to develop the global testing about if all the coefficients are zero, or at least one coefficient, it doesn't matter, or at least one coefficient can independent variables can explain the variations or change in the dependent variable. And also, this is the whole thing will be the content in our final exam. In the final exam, I will give you one or couple of the questions, just like the example of the heating cost. So you're gonna use the Excel to do the analysis and find out all your coefficients, the constant number, and your if value from the output, and then you're gonna develop the equation and use it to do some estimations of the dependent variables, and then you're gonna perform or operate a global testing, then get your conclusion. That's it. If you have any questions, please send me email to ask, or send me email with set a time. Okay, thanks.